Hello guys, welcome to Algorithms Made Easy. My name is Rajat and today we will be discussing the question remove all adjacent duplicates in string part 2. In this question we are given a string S and a k duplicate removal consisting of choosing k adjacent and equal letters from S and removing them, causing the left and the right side of the deleted substring to concatenate together. We repeatedly make k duplicate removals on S until we no longer can. We return the final string after all such duplicate removals and it is guaranteed that the answer is unique. In the first example, we see that there exists no two same character that we can remove, so the output is the original string. In the second example, we can first remove the triple E that is present, as the k is 3. So we first remove that. After that we remove the triple C. Then we get this string. And here we can see we can remove the triple B. Once we remove that, we have this string which contains triple D, and at the end the string that remains is double A. And similarly in the example 3, the given constraints with the problem state that the length can reach up to 10 raised to power 5, k can be up to 10 raised to power 4, and the string will contain only lowercase English letters. So now we'll see how we can solve this problem, and we'll start off by explaining the approach that I first used in this problem to solve it. So suppose this is the string given to us and the value of the k is 3. We need a data structure which works in that fashion wherein we can remove the threshold when it is reached, and then we can work from that position till the end of the string. So the data structure which helps us achieve that kind of approach is called stack. So in this question we will be using a stack, and in this stack we'll start off with iterating over the string character by character. Starting with the first character D, we'll push that character into the stack, and then we push the next character, and then we push the next character, and then we reach the third E. Now these three E forms a substring which needs to be removed as they meet the condition of the substring which needs to be removed from the original string. So we need to just pop out all the E's that are present in this stack. How do we pop out the values, and how can we know that the number of E's present in this stack has reached 3? Let's move backward and we'll have all our characters into the stack. And now let's move one step back and remove the current character from the stack. We are now at this character which is the third E, and we are trying to put that into stack or not. Now if it satisfies certain condition, that is including this, the string is now of length 3 forming with the same character, we need to remove all those values from the main stack. So now we will have two stacks, one main stack and other is a temporary stack, and we will put the current character in each case into this stack first, and then we will compare the value of the top of the main stack with the value that is at the top of the temporary stack, or we can say the current character. If the two value matches, we shift the value from the main stack to the temporary stack, and we will do that till the character doesn't match. So we have this temp stack with all the same values, and the main stack now contains the resultant string. Now if this temporary stack is of the size k, then we are sure that it contains a continuous string of same character of length k. So we can just directly discard this temporary stack, and now the main stack contains our resultant string, and we can continue moving forward in this fashion. But now what if the character present at the top of the main stack is k, which does not match the character E? So we cannot shift this k from the main stack to the temporary stack, and also the temporary stack size is not equals to k. So a continuous string of same character of length k is not present. So we need to move all the values that are present in this temporary stack into the main stack. So that becomes our second case when the temporary stack is not of the size k. So we move each of the value one by one into the main stack. Now once we have removed the three E's, we move to the second character, we move to the next character D and then put it into the stack, and then we put B into the stack, and we will continue doing so, removing the values as and when we reach a threshold of k continuous values from the resultant string. At the end, this stack contains the resultant string, and we will take that into a string builder, and as stack works in a LIFO fashion, we need to reverse that string at the end of the program. So now let's try to code this particular approach. So as discussed, we need a main stack of character, and now we need to iterate over this string character array. As we discussed, we need a temporary stack for each of this character that we are working with. So we'll create a temporary stack. We will first push the value into this temporary stack, the current character. While the main stack is not empty and its top character is equals to the current character, we'll keep on adding the values into this temporary stack, popping the values from the main stack. Now, only if the size of this temporary stack is not equals to k, we need to move all those values present in this temporary stack into the main stack. Once all this is done, we will have our result into the main stack, and we can have that result by using string builder. We will loop on this main stack till it is empty, and now we append the value present in the stack into this string builder. At the end, we need to reverse the string builder, as we discussed that stack is in LIFO fashion, and then we convert this reverse string into a string. Let's try to run this code. So it ran successfully for all the test cases. Let's submit this. It doesn't got submitted successfully, and the reason was a time limit exceeded. Now, a time limit exceeded is expected in this case, as we are doing too much operations while trying to move the value first into the temporary stack, and if it is not, then we are again moving that value into the main stack. The time complexity in this case is n into k, while the space complexity is n. So now let's see how we can optimize this approach. Coming back to the previous example, we had two stacks, main stack and temporary stack, and we were putting the value into the temporary stack, and then if the size of the temporary stack doesn't reach the value k, we move the value from the temporary stack to the main stack. So how we can have an approach where we do not need a temporary stack? How about there is an easy way to find out if there exists continuous character whose length is equals to k. So if you focus our attention on the main stack, wouldn't it make much more sense if we combine the 2a and write it as a key value pair, wherein we first have the character and then the count of it in the continuous way. So now we do not need a temporary stack, and when we encounter another character, we put that character at the top. This is just for the reference. Check if the below value is equal or not, and then we can increment the count of it. So now all we need to do is check if the character at the top of this stack has a count equals to k. If the count is same, we can pop this value directly, and then there is no need of moving the characters back and forth in the temporary or the main stack. So as we are using a key value pair in this approach, we can use a pair class for that, which is inbuilt in Java. We can also use an integer array of size 2, as a character and integer are interchangeable. We will use an integer array in this approach. So now it's time to code this particular approach. So we'll have the same method. So we will just change the for loop. Now only if the main stack is not empty and the value present at the top is equals to the current character, we need to increment the count of it. Otherwise, we need to push a new character array, wherein the first value will be the character and the second value will be 1, which is the count of that character. And now if the value at the top, that is the count of the top character, is equals to k, then we need to simply pop that value from the stack. Once this is done, we have the resultant string into the main stack. So we'll first pop the value, which we can take in the variable. Now while this count 0, we'll append this character present at the top, and everything else remains the same. So now let's try to run this code. So it ran successfully. Let's submit it. So it got submitted successfully. The time and space complexity in this case is O of n, and this is quite an optimized solution. Now there is one more way which doesn't uses any stack also. So now let's see that as well. So we will take the same example now also. Now let us turn our attention to the string given to us, and in this string what we effectively need to find a string of same character forming a substring of length k, in this case 3. If we iterate on this string and find that string will first find these 3 characters. So we can reduce this string by removing all those 3 characters. We can do that by using a substring function for both the values, before this particular string and after this particular string. And now we'll again do the same thing on the remaining string, finding a string of character of length k and then removing it, and continuously doing that till we reach a particular string which does not have any substring with length 3. So at the end we will return this particular result. So this now becomes a recursive solution where we are at each step reducing the string given to us and then again doing the same operation which we did on the original string. So now let's try to code this particular approach. So we need to know the count of continuous same character. So we'll have count 1. We are doing that because we are starting our iteration from the first index, going all the way to the length of the string. If the character present at index before this I is equals to this particular current index, we can increment the counter. So if the character at I is equals to the character at I minus 1, we can increment the count. Otherwise, we are sure that the previous character won't match. So we need to reset our counter, resetting counter to again 1. Now, if the counter at this particular index reached k, that means there are k continuous same characters in the string. Now we need to reduce the original string by removing the continuous k length string. So we will take that into a string called reduce string, and the new reduced string will be as dot substring starting from 0 till I minus k plus 1, and then starting from I plus 1 till the end of the length of the string. Then we need to call the same method called remove duplicates on this reduced string. If we do not find any reduced string, then the answer remains the same string which we have got. So this completes the coding part for this approach. Now let's try to run this test case. So it got successful. Let's submit this. So it is submitted successfully. The time and space complexity still remains often. Do let us know your thoughts in the comments below. Thanks for watching this video. See you in the next one.